Hello everyone, my name is Dnyaneshwari Bhosale, a computer engineering student at MIT. Welcome to my YouTube channel dedicating to exciting world of cybersecurity. So, welcome back to the next part of the video, that is introduction to cybersecurity part 2. So, the next topic we'll be seeing in this video is security violations. So, imagine you are sending a confidential message, but an unauthorized person reads or even changes it before it reaches to the recipient. This is a serious security violation, and today we'll break it down with real world examples. So the first one will be unauthorized access to sensitive data. So imagine user A is transmitting a file with sensitive information to user B. However, user C, who is not authorized, gains the access and reads the file. This is violation of confidentiality because only authorized users should have access to the sensitive data. For example, imagine sending a bank statement to your accountant, but the hacker intercepts and reads it. Second example, unauthorized access to files over a network. So imagine an attacker or unauthorized person manages to access files on the network. This could happen due to weak passwords, unencrypted files, or network vulnerabilities. This is a direct security breach that can lead to data leaks and identify theft. For example, a hacker exploits an open Wi Fi network and accesses private company files. Third example, message modification, that is data integrity violation. So imagine a user A sends message to user B, but before it arrives, user C intercepts and modifies the message. So user B receives an altered message leading to potential miscommunication or fraud. This violates data integrity because the original information was changed. For example, a hacker intercepts an email from the CEO of the finance team, modifies the bank account details, and steals the company funds. So the next terminologies we'll be seeing is encryption techniques, plain text, and ciphertext. So in today's digital world, data security is more important than ever. Have you ever wondered how sensitive information stays protected online? The answer lies in encryption. So let's break down the key terms you need to know. So the importance of data protection. So data is like a personal asset. It holds value and must be protected from all the unauthorized access and its modifications. So hackers and cyber criminals often target sensitive information, making encryption and crucial defense mechanisms. For example, think about your online banking details. If they were transmitted as plain text, anyone could have read them. Encryption prevents that. So, basically, what is encryption? Encryption is a technique used to hide information from the unauthorized users. It ensures that only authorized parties can access and understand them. Encryption also protects information from being changed by the attackers. For example, when you send a message on WhatsApp, it is encrypted so that no one except the intended recipient can read it. Next topic is plain text. So, this plain text is a original, readable form of data before encryption. It is converted into ciphertext using an encryption algorithm. For example, if you type hello in a message, it is a plain text. And let us say ciphertext. So, this is an encrypted version of the plain text. It making it unreadable to unauthorized users. It is also known as scrambled message because it looks like any random character. For example, hello could be converted into something like numericals or any logos or any capital and small letters after encryption. So let us take a real time example. Imagine locking a diary with a key. The words inside that are plain text are readable, but once you lock the key, only the person with the once you lock, only the person with a key can read it. Ciphertext is the locked version of the diary. So let us see the next slide, that is encryption. So have you ever wondered how your private messages stay safe online? So encryption is the answer. Let's break down the process step by step. What is encryption? So, encryption is a process of converting readable text, that is plain text, into the scrambled, unreadable format, that is also known as ciphertext, to prevent unauthorized access. Only someone with the right decryption key can convert it back to the readable text. For example, imagine writing a secret note and using a special code to scramble the letters. Only someone who knows the code can read it. Second, key terms in the encryption. That is, first one is plain text, the original readable message. Second is encryption, the process of converting plain text into the ciphertext. And third one is ciphertext, that is the encrypted, unreadable form of the message. For example, if you type plain text hello after encryption, it can be in a unscrambled format, that is any format of small letters, capital letters, or so symbol, logos, or numericals. Third, how encryption works. With we'll see a formula that is in the slide, that is C equals to E bracket P. This means that when we apply an encryption algorithm E to the plain text P, we get ciphertext, that is C. The process is shown in the slide, that is diagram. Plain text gives encryption and then it gives ciphertext. For example, if you send a password online, encryption ensures that hackers cannot read it if they intercept the message. Let us go to the next slide, that is decryption. So in the last slide we discussed about how encryption secures the data by converting plain text into ciphertext, but how do we get back the original message? So that's where decryption comes in. So let's break down decryption process. So decryption is a process of restoring the original plain text from ciphertext. It reverses the encryption, making data readable again. For example, imagine you received a coded message from a friend. Decryption is like using secret key to decode the message and understand what is originally written in it. Key terms in decryption are ciphertext, decryption method, and plain text. Like we seen in the last slide, ciphertext is scrambled message. Decryption is the process of converting ciphertext back to the plain text, and plain text is a readable message after decryption. Let us see a real life example while seeing the formula. When you receive an encrypted email, your device decrypts it so you can read it. However, let's see the formula, how decryption works. The slide presents a decryption function, that is P equals to D bracket C. This means that when we apply a decryption algorithm D to the ciphertext C, we will get back the plain text, that is shown as ciphertext, then decryption process, then we'll get the plain text. If encryption scrambled hello into some any format of scrambled message, the decryption converts it back to the hello. So let us move forward to the next slide, that is cryptography. So have you wondered how secret messages stay hidden from prying eyes? In this slide, we'll explore cryptography, the science of securing information, and cryptanalysis, the art of breaking the codes. So firstly, we'll see what is cryptography. The word cryptography comes from Greek word that is cryptos. The meaning of it is secret or hidden. It is both an art and science used it to encode messages, making them unreadable to unauthorized individuals. Cryptography involves various encryption techniques that ensure safety and privacy first. So let us see a real life example. When you send an WhatsApp message, it is encrypted so that only intended recipient can read it. Next part is cryptanalysis. So cryptanalysis is a person who studies encryption and decryption methods to uncover hidden messages. Their goal is to analyze, break, or decode encryption data without having the original decryption key. The process of breaking ciphertext and recovering plain text is also called as cryptanalysis. So, the example of cryptanalysis is code breakers in World War II cracked secret enemy communications to gain the intelligence. So the next part is cryptology. How do encryption and code breaking work together, and what role does a secret key play in securing the data? In this slide we'll explore the concepts of cryptology and encryption keys. So what is cryptology? It is basically a border field that includes both cryptography, the art of securing information through encryption, as well as cryptanalysis, the science of breaking encrypted messages. Cryptology combines both securing and breaking codes to enhance cybersecurity. For example, modern cybersecurity experts use cryptology to both design encryption methods and test their security. So, what is key in encryption? Key is a secret number or information used in encryption and decryption algorithms. The key is only known by the sender and receiver, ensuring data confidentiality. Without the correct key, deciphering an encrypted message is extremely difficult. For example, think of a key like a password that locks and unlocks secret messages. In bank transactions, encryption key protects your sensitive data from hackers. So, moving forward to the next slide, crypt- uh, cryptographic attack methods. So, how do hackers break encrypted messages? In this slide, we'll explore five cryptographic attack methods used to compromise security. So, the first one is known plain text. Second, chosen plain text attack. Third, cipher uh, cipher text attack only. Fourth, chosen cipher text attack. Fifth, side channel attack. So, one by one, we'll see these attack methods. First, known plain text attack. Have you ever wondered how hackers break encrypted messages if they already know part of the original text? Today we'll explore the known plain text attack, that is KPA, and how it threatens cryptographic security. So let us know what is known plain text attack. It occurs when the attacker has both the plain text, that is original message, as well as the corresponding cipher text, that is the encrypted version. By studying the relationship between them, hackers attempt to extract encryption keys. Reverse engine the encryption processes, find weakness in a cryptographic algorithm. So why known plain text attack is dangerous? If an attacker finds a pattern between plain text and cipher text, they can predict future encrypted messages, decrypt past communications, and compromise entire security systems. For example, imagine an encrypted military message that repeats the phrase top secret. If an attacker see its cipher text multiple times, they may guess the encrypted pattern. So, how non-plain text attack works step by step. First is intercept communication. The attackers obtain both plain text and cipher text as well. Second one is analyze encryption patterns. They compare the original message with its encrypted version. Third is derive the encryption key using mathematical analysis. They try to reverse engineer the key. Fourth is decrypt future messages. If successful, the attacker can decrypt similar data in the future, encrypted data in the future. So the next attack is cipher text attack only. How do hackers break encryption when they don't know the original message? Today we'll see one of the toughest cryptographic attack methods, that is the cipher text attack only, COA. So what is cipher text attack? It happens when an attacker has access to only encrypted messages, that is cipher text, but doesn't know the original plain text and the encryption key as well. So the hacker's goal is to recover the original plain text message, guess or derive the secret encryption key. So why cipher text attack only is dangerous? So if an attacker successfully breaks one encryption key, they can decrypt all the messages that use the same key. So this can lead to stolen sensitive data such as passwords, banking information, and classified messages, compromise communication channels, and massive security breaches. So let us see a real world example. So imagine a spy intercepting multiple encrypted messages. If they break one message, they might decrypt all similar messages sent using the same encryption key. So we'll see how a ciphertext attack only works step by step. So first one is it collects ciphertext. The attacker gathers multiple encrypted messages. Second, it analyzes the patterns. They search for repetitive structures, frequencies, or weakness in an encryption method. Third is they guess or compute the key. Using mathematical techniques, they try to derive the encryption key. And the last one is they decrypt other messages. Once they find out the key, they decrypt other messages encrypted with the same key. The next attack is chosen plain text attack. What if an attacker could choose any message they want to see how it's encrypted? That's exactly what happens in a chosen plain text attacks, that is CPA. Today we'll break down this dangerous cryptographic attack. So what is a chosen plain text attack? It is when a attacker chooses a specific plain text message to be encrypted, obtains the corresponding ciphertext generates by encryption system, analyzes the pattern to uncover the encryption key or algorithm weaknesses. So let us see how chosen plain text attack works. Step 1, the attacker selects a plain text and the attacker submits a known message or multiple messages for encryption. Step 2, it gets the corresponding ciphertext. The encryption system processes the plain text and returns the encrypted data. Step 3, that is it analyzes patterns. The attacker studies how plain text map to ciphertext, helping them discover the encryption method. And step 4 is it cracks the encryption key. Without enough data, the attacker can reconstruct or guess the encryption key. So let us see why chosen plain text attack is dangerous. So first reason is encryption key exposure. The cryptanalysis can extract the key if the encryption system is weak. Second, breaking public key encryption. If public keys are accessible, attackers can manipulate encryption. And the last one is decryption of future messages. If the key is compromised, all encrypted messages can be decrypted. So let us see a real world example, that is RSA public key attackers. If an attacker has access to encryption, they can submit text, plain text, and analyze responses to find out the vulnerabilities. What are the measures against the chosen plain text attacks? So first one is using strong and randomized encryption. That is, for example, AES RSA with padding. It prevents pattern detection. Second is implementing non-deterministic encryption. That is, add randomness to ciphertext. Third is secure public key crypto system. That is, prevent unauthorized access to encryption mechanisms. And the last one is limited access to encryption systems. That is, only authorized user should submit plain text for encryption. So the next one is chosen ciphertext attack, that is CCA. What if an attacker could manipulate encrypted messages to reveal secret data or even extract encryption keys using hardware signals? Today we will cover two powerful cryptographic attacks, that is chosen ciphertext attack and side channel attack. So let us see first, that is chosen ciphertext attack, that is CCA. A chosen ciphertext attack occurs when a cryptanalysis selects a ciphertext and attempts to find the corresponding plain text, or else it interacts with decryption system, gaining temporary access to see how the ciphertext gets decrypted, and it uses the decrypted output to analyze the encryption algorithm and break down the security. So let us see how choosing ciphertext attack works. Step 1, the attacker chooses a ciphertext and submit it for decryption. Step 2, that is the system returns the decrypted plain text or an error response. Step 3, by analyzing the multiple inputs and outputs, the attacker determines patterns exposing weaknesses. And step 4, eventually they recover the secret key to decrypt messages without authorization. So let us see a real world example, that is padding oracle attack, that is POA. An attacker submits modified ciphertext and uses error message to recover plain text, often affecting SSL and TLS methods. So the next one is side channel attack, that is SCA. So unlike traditional cryptanalysis, side channel attack don't directly target the encryption algorithm. Instead, they analyze physical and hardware signals, the signals that are CPU usage, power consumption, as well as time delays. It identifies cryptographic hardware software details like chip vulnerabilities and key storage. It exploits system weakness in timing, electromagnetic radiation, or even sound waves. So, how does SCA works? That is step one, the attacker monitors system behavior during the encryption or decryption. Step two, they collect data like power usage, processing time, voltage fluctuations, and CPU heat output. Step 3, using advanced analysis techniques, they extract cryptographic keys or break down security measures. So let us see a real world example, that is timing attacks. Observing how long an encryption operation takes or reveals secret keys. The next one is electromagnetic attacks, that is capturing signals from chips to reconstruct the encrypted data. So, why these attacks are dangerous? The chosen cipher text attack allows attackers to manipulate encryption decryption processes, exposing sensitive information. And side channel attack extracts cryptographic secrets without breaking the encryption itself, making it hard to detect. Both attacks can be used together, making modern cryptography vulnerable. Defense against these attacks, this against these both attacks are using a strong encryption, that is AES RSA with OEAP padding methods. It prevents chosen ciphertext attacks exploitation. Second is disable decryption oracle access, that is it stops attackers from getting decrypted outputs. Third one is implementing power and timing protections, that is it prevents side channel data leaks. And the last one is using secure hardware modules, that is HSMS. It protects cryptographic keys from physical analysis.